Hey folks, so welcome to another lesson. Today we're going to look at circuit symbols, and I know some of you might know these already. Some of you might not, because you were all in different second year classes. So what I'm really doing now is to make sure everybody has the same basic knowledge. So some of you will find this revision, others will be finding this new content. So what we're going to learn today is to identify the different circuit symbols, and you can remember these. We're going to describe what each component does, and again, you need to remember these. And then we're going to draw out circuit diagrams using circuit symbols. And this is really useful because later on, when we come to do some experimental work, we're going to use these circuit diagrams to describe what we're doing. So a really, really important lesson for us today, folks. So for these symbols, what I would recommend is you copy out the symbol on one side and you write what they do on the other side. And I've included a worksheet for you to do this so you know the format that I want you to do this. And that way you've got a wee guide to help you revise what the symbols are and what they mean. So the first one we're going to do is a cell, and this converts chemical energy into electrical energy. And this is a bit confusing, but this is actually a cell. I know we call this a battery, but a cell is really when you've got a single battery. And if you do chemistry, you'll talk about cells meaning one battery as well. So what do we call a battery in physics? Well, a battery is when you've got two or more cells joined together. So that would mean you've got two or more of these cells joined together. That's what we call a battery. Now, before I forget, in the symbol for a cell, the short line stands for the negative terminal and the long line stands for the positive terminal. We don't normally draw these symbols in, we just assume you know them. If we're doing this in class, I would show you this with some practical, and you could do this yourself. But when we connect two cells together, they always have to go positive, negative, positive, negative, positive. And if you think about it, remember, like charges repel, unlike charges attract. So that's why you've got to have them the opposite way around when you connect them together. Next one is a resistor, and this reduces current if the resistance gets bigger, and they look like this. Usually we'll have these mounted onto little boards, so you're not actually touching these for real, and I'll show you these when we get back into class. And a switch, which is basically just to allow the current to be turned on and off. And this is called a digital input device. So it's worth you remembering that because I'm going to assess you on this. So a switch is a digital input device, and it basically switches things on or off. Okay, so the second out of three slides, the next one is an analog output device. So again, you need to remember this, an analog output device. I'll explain what analog and digital are a bit later on. But the first one is a lamp, which converts electrical energy to light energy. I'm quite bad because sometimes I'll call a lamp a bulb as well. Now, in the PhET simulation, if I'm correct, I think they use this symbol to represent a bulb, and that's actually the American symbol for a bulb. We're going to use this one in our class and homeworks and tests, etc. Variable resistor, this allows the current to be controlled, so it looks just like a resistor, but there's an arrow going through it, and that arrow shows or means it can be changed around. This is what a variable resistor looks like. These are the really big, bulky ones. We're going to use smaller versions of these. A heater changes electrical energy into heat energy. Notice it's got the same shape as a resistor, but it just has these lines down them, and we'll look at why that is later on. There's a reason why these symbols are kind of connected together. And then a motor, which is used to change electrical energy into kinetic or movement energy. I'm not fussy which one you use, they both mean the same thing. I would prefer to try and use kinetic because that's a more kind of technical term. So try and work on your literacy and take on board these new words that I'm showing you. Okay, final set of symbols here. And the first one is an ammeter, which measures current in amps. Again, we'll look at these in more detail later on. You may have seen them in the PhET simulation if you've had a look at that already. The voltmeter measures voltage in volts, and again, we'll talk about that a bit later on. The ohmmeter, which measures resistance in ohms. All of these I would like you to have a chance to use in class when we get back into class. And then my favourite meter of them all is the Lamb meter, which measures Lamborghinis in lambs. Okay. Okay, so let's use these symbols to draw electric circuit diagrams. Why do we draw these circuit diagrams? Well, if you look at the cartoon down here, you can see it's quite a nice cartoon, but it would take a lot of time to draw it, and you might draw it differently from what we're shown. So the idea of the electric circuit diagram is that it's nice and simple for you to draw. Also, if you draw the diagram and someone else looks at it, they should be able to understand exactly what it is that you've drawn. So here's what I want you to do to draw these circuit diagrams. The first thing is you should always draw them using a ruler. Now, if you don't have a ruler at home, that's fine. You can use anything that has a straight edge so that you can draw a straight line. They show us how the components are connected to make a circuit. And here's what the circuit diagram for this cartoon would look like. Okay, so a couple of things to note here. Notice we only have one cell here, so that's why we draw the symbol for a cell. We've got the lamp here, and then we've got the switch. Now, for the switch, to make it a bit more obvious that it is a switch, you can draw these wee circles in there. I tend not to because it's just a wee bit of extra work, so I'm a wee bit lazy, so I tend to just draw them as the one that I've shown you earlier on. We draw the wires as straight lines like this. So these are the wires or the leads as they're really called. Okay. And notice how the circuit diagram is in a rectangular or a square shape. We don't draw it like a curly line like this. We draw it in a square box or rectangle. Number one, because it looks nice and neat. Number two, because it's easier to draw squares and rectangle if you're using a ruler. So that's how we draw our circuit diagrams. And this type of circuit is called a series circuit because all the components are connected one after another like this. Okay, we'll look at series circuits in more detail later on, but for just now, make sure you understand how to draw these circuits. Okay, so let's look at a worked example together. Now, how would you draw this as a circuit? And notice it looks like before where we've got a battery connected to a lamp, but then the lamp has another lamp connected to it. But that second lamp isn't directly connected to the battery. So how do we draw the circuit? Well, first of all, it's a cell. So we draw our symbol for a cell. Now, obviously, you're going to use a ruler to do this, so it'll look a lot neater than mine's. I'm doing this on my PowerPoint, so it's harder for me to do it as neat as you guys are going to do. And then we draw the lead going down the way. Remember, you're drawing squares and rectangles for the overall circuit. We know there's a bulb connected to the first battery cell, sorry. Correct me if I ever say battery when I mean cell, folks. So that's the first part of the circuit, and it's pretty much the same as the other one. Can you remember what this type of circuit is called? A series circuit, and that's because these things are connected one after another in series. Now, to get the second lamp, we know the second lamp is connected across the first lamp. So to do that in a diagram, we just do the same thing. We connect it across it like this, and that is our circuit diagram complete. Okay, obviously draw the lines connecting into the bulb to show that it is actually connected, and that's it. Now, this is a special type of circuit some of you might know already. It's called a parallel circuit. And it's called a parallel circuit because you can see the bulb, the cell are all parallel to each other. Okay, so these are all parallel to each other. So that's the second type of circuit we're going to look at later on in the course. So what I'd like you to do is, as part of your assignment, to draw the following cartoons into a circuit diagram form. I'll put these on a worksheet so you can see them separately. So notice these are both series circuits. So I'll leave you to do that as your assignment. The same with these ones, but notice these are parallel circuits. So I would like you to draw these as parallel circuits.